Our discussion today will be narrowed to dimensional analysis of gravitational constant. This is the most widely asked question in both external and internal exams. If you are new to this channel, please kindly hit the subscription button so that you don't miss videos like this. The question we have today says, what is the value of x, y, and z in dimensional analysis of gravitational constant? According to Newton's law of universal gravitation, it states that force of attraction between two objects of mass, say m1 and m2, is directly proportional to the product of the masses and inversely proportional to the square of the distance separating them. Mathematically, the law can be represented as F being directly proportional to m1, m2 all over r squared, where F is the force, m1, m2 are the masses of the two objects, and r is the distance separating m1 and m2. In getting the gravitational constant, you can simply remove the sign of proportionality to introduce constant. Then you have F is equal to g m1 m2 all over r squared. Like we all know, whenever you remove sign of proportionality, you introduce constant. We can go ahead to cross multiply, and then it will give us g m1 m2 is equal to f r squared. Since we are looking for dimensional analysis of gravitational constant, we are going to make G subject of the formula. Then you have G is equal to F r squared all over the coefficient of G, which is m1, m2. The F we have here is our normal force, and the force is the same thing as mass times acceleration, where mass is measured in kg and acceleration is measured in meter per second square. R squared is distance, and distance is measured in meter. So you have m. Everything all over m1, m2. And mass is measured in kilogram. That is kg into 2. The first mass in kg, and the second one in kg also. So that is kg squared. Then we have kg, the meter here, multiplied by the meter here. According to the law of indices, in multiplying numbers with the same base, you add up the powers. So the power here is 1, and the power in the second m is 2. 1 plus 2 give us 3. That is m raised to power 3. Everything all over s squared, which is time. Then multiply by 1 over kg squared. Kg multiplied by kg is kg squared. If this kg squared should come up, that means you are going to have 1 minus 2 from the law of indices, which is minus 1. Then we have m raised to power 3. And lastly, s raised to power minus 2. Because here is at the denominator. If it should come up, the power will change from positive to negative. Kg is the SI unit of mass, so you write mass boldly. And the power is raised to minus 1. Meter is the SI unit of length, so you write L raised to power 3. Then second is the SI unit of time. You're going to write time, which is T raised to power minus 2. Don't forget, the question says find the value of x, y, and z. We've succeeded in getting the powers of the fundamental quantities. Like we all know, the three major fundamental quantities are the mass, length, and time. And these are the three components of the gravitational constant. We are going to compare these with the three fundamental quantities. In the fundamental quantities, m is raised to power x, l to power y, and t to power z. Therefore, since you are looking for the values of x, y, z, you can represent them in the same order which they appear here, thereby having x to be equals to minus 1, y is equals to 3, and z is equals to -2. With these hints, I believe we've done justice to gravitational constant analysis. So if this video was helpful, kindly hit the subscription button as I keep updating you on everything concerning science and engineering. Thank you and God bless you.